In this video, we will discuss special cases of solving systems of equations by substitution. First, let's discuss the different types of special cases you may see. If the system results in a true statement, then there is infinitely many solutions, because it's always true, so any number would work. An example that you may see is if you see something like 5 equals 5, then it means it's a true statement, so it's infinitely many solutions. If the system results in a false statement, then there is no solution, because there's no set of numbers that will ever make it true. So if you see something such as 4 equals 0, which is false, that would mean it's no solution. In our first example, our two equations are x plus 3y equals negative 11 and negative 2x minus 6y equals 22. Again, in order to solve the system, we have to choose a variable to get by itself. So in this case, the x is the smallest variable, so we're going to solve to get that variable by itself. In order to do so, we'd have to subtract 3y from both sides, and we'd get x equals negative 11 minus 3y. And since the x is already by itself, I can take this entire expression and plug it in for x in the other equation. So you'll have negative 2 times negative 11 minus 3y minus 6y equals 22. Now to solve, you have to first distribute. So you'll get 22 plus 6y minus 6y equals 22. Then if you get combine like terms, you'll get 22 plus 0y equals 22. Now that 0y can really be just written as if nothing's there. So it really means 22 equals 22. Now since this is a true statement, this means that there is infinitely many solutions. In our next example, our two equations are 2x plus 10y equals 7 and negative x minus 5y equals negative 1. Now again, we have to choose a variable to get by itself. In this case, since the negative x has the smallest coefficient, that's the one we want to solve to get by itself. So in order to get it by itself, I first have to add 5y to both sides. So you get negative x equals negative 1 plus 5y, and then divide both sides by a negative 1 to get rid of that negative in front of the x. This becomes x equals 1 minus 5y. Now you can take this entire expression and plug it in for x in the other equation. So it becomes 2 times 1 minus 5y plus 10y equals 7. To solve, we'd have to distribute. So you have 2 minus 10y plus 10y equals 7. The negative 10y plus 10y becomes 2 plus 0y equals 7. And again, we don't have to write that 0. So it becomes 2 equals 7. Now since this is false, this means that there is no solution to the system.